Algebra 2, Set 17, Subscripted Variables and Angle Relationships. Okay, so subscripted variables, basically the reason why we use subscripted variables is to help avoid confusion because they tell you what the variables represent. So instead of having something like x plus y equals 40, you have n to the n sub n plus n sub d equals 40. So x plus y doesn't really tell you what you're working with, but if you have n sub n plus n sub d, you can kind of remember that n sub n is the number of nickels and n sub d is the number of dimes. So that's basically why we would use subscripted variables. So we'll just do some examples. Solve these equations. The n sub n's and the n sub d's are just like x's and y's. So we'll take that top equation and multiply everything by -5 so that we can eliminate. So we get -5 n sub n minus 5 n sub d equals -200. Now we can add those two equations and we get 5 n sub d equals 50, so n sub d equals 10. We can take that and plug it into that top equation. N sub n plus 10 equals 40, so n sub n has to equal 30. Solve the following system of equations. So in this case, you've got a lot of different pieces of information. R sub m t sub m plus r sub w t sub w equals 260. R sub m is 40, r sub w is 60, and t sub m plus t sub w equals 5. So the easiest thing to plug in right here is r sub m and r sub w that equal 40 and 60. So we'll plug those two in. We get 40 t sub m plus 60 t sub w equals 260. Now we're going to go over to this t sub m and t sub w, and we will solve for one of them. It doesn't matter which one you solve for. So we'll solve for t sub m. So we just subtract t sub w from both sides. So we get t sub m equals 5 minus t sub w, and now we can take that and plug it in. So 40 times 5 minus t sub w plus 60 t sub w equals 260. We distribute, we get 200 minus 40 t sub w plus 60 t sub w equals 260. We'll put -40 plus 60 to get 20 t sub w, and then we'll subtract 200 from both sides and we get 60. So t sub w equals 3. Then we take that and plug it into that top equation of t sub m plus t sub w, and we get t sub m plus 3 equals 5, so t sub m equals 2. Angle relationships. So if you have two unknowns in these angle relationships, like x and y, then you're going to need two unique equations. So anytime that you have unknowns, you know that you need to have the same number of equations as unknowns. So for example, this says find x and y, and since we have x and y, we're going to need two equations to solve. So the first thing that we can see is that 7x minus 2y and 50 are all on a straight angle. So when we add them together, we get 180. So that will be our first equation, 7x minus 2y. And then instead of putting plus 50 equals 180, we can just subtract 50 from 180. So we know that 7x minus 2y has to equal 130. The next thing that I see is we have parallel lines cut by a transversal. So if you have parallel lines cut by a transversal, you have large angles and small angles. So 50 is a small angle, and 5x minus 10y is also a small angle, so we can set them equal to each other. So 5x minus 10y equals 50. From here, we just need to solve these two equations. So I'm going to solve by elimination, which means I'm going to multiply everything in the top equation by -5. So we get -35x plus 10y equals -650. When we add those two together, we get -30x equals -600. So in this case, x is going to equal 20. So if x equals 20, we're going to take that and plug it in. So 7 times 20 minus 2y equals 130. So 140 minus 2y equals 30. Negative 2y equals negative 10, so y equals 5. And that's the solution.